Hey guys, welcome back to Civil Learning Online. And today in this video I am going to discuss about an example which is based upon the divergence theorem, and it is going to be helpful for all those students who are studying engineering mathematics first. And here this example is very important from the exam point of view, and in the previous video I have discussed about the Green's theorem, and there are two examples. If you want more examples, then you can leave the comment. And without any further delay, let's get started. So the numerical is about the divergence theorem. So one must have the concept or know what the divergence theorem says, and here I have selected it. The formula is here volumetric integration of divergence of vector f. Delta represents the divergence. Delta, it is not called delta, it is nebula, or del f vector. Del means divergence of vector f will be equals to surface integration of the product of vector f, and this n cap is the normal vector normal to that surface. This s is surface integration, and this is delta ds, and n cap is the unit vector which is given by gradient of phi divided by the determinant of gradient of phi. Now one must have some basic concept or some basic integration, that is integration of x to the power n dx will be equals to x to the power n plus 1 divided by n plus 1. These are the, so here I am writing some formulas which we will be needing in this numerical. So now same will be case for y also, means y to the power n will be integration with respect to y will be equals to y to the power n plus 1 upon n plus 1. Similarly will be the z for z also. Similarly, if we are integrating any constant, means there is not any negative or no any term of x, or we can say x to the power 0, means 0 means 1. Integrating with respect to x, then we need to put x here. Similarly, if we are integrating with respect to y, we need to write y. I hope you understood these things. Now let us move toward the solution of this numerical, and for that let us proceed by writing solution. And we have f vector equals to 4x multiplied by unit vector along the x-axis, that is I cap, minus 2y square. Z cap is the unit vector along the y-axis. Similarly z square k cap. Now as per the theorem, we can see that first of all we need to find the divergence of vector f. So how we can find? See here, divergence of f vector will be equals to curl upon curl x times I cap plus curl upon curl y times j cap plus curl upon curl z times k cap, and multiplying this with f vector, means 4x times I cap minus 2y square times j cap plus z square times k cap. Now here on multiplying, I will when I is multiplied with I, then we will get 1. When I is multiplied with j, then it will become 0. So due to that reason, we will only write a term which are the product of I cap and I cap. So multiplying I cap and I cap, we will have curl upon curl x times 4x. Similarly, if I and j is multiplied, then it gets 0, so we will omit this. Similarly, now curl upon curl y, and j is multiplied with j, so minus 2y square plus curl upon curl z, k is multiplied with k, so z square. Now derivative with respect to x, we will get 4 minus 2 is multiplied in derivative of y square. We know that derivative of x to the power n upon dx will be x to the power n minus n times x to the power n minus 1. So here n is 2, so here first of all we will rewrite this 2 as it is, and this n means 2 y to the power n minus 1. N minus 1 means 2 minus 1 will be 1 and positive z square. Z square means 2 times n times z to the power 2 minus 1 means 1. So we will have 4 minus 4y plus 2z. This is the divergence of vector f. Now we will write here volumetric integration of divergence of vector f dv will be equals to now volumetric means one will be for x, y and z. So we will put the limit of x, y, z now. And see here guys, in the question limit of z is already given 0 to 3. So write it here 0 to 3. And value of divergence of f is 4 minus 4y plus 2z dz dy and dx. Now how we will have the value or limit of y. See here, we are given with the equation of the base of the cylinder. Cylinder has a circular face. See here, so cylinder has circular face, and we are given with the equation that is x square plus y square equals to 4. Means the circle has a equation x square plus y square equals to 4. Means radius of the circle we are provided with the equation that is x square plus y square equals to 4. Means radius of the circle, because we know that x square plus y square equals to r square is the equation of circle. So we will have r equals to 2. R square means 2. 4 is equal to 2 square, so radius of circle is 2. So here it is 2. And z, this is our z axis. Similarly, this is our y axis. Oh sorry, it wasn't visible. And this is x, and with radius we come to know that radius is 0. And on xy axis we will have z equals to 0. So here at base z is equals to 0, and at height we have z equals to 3. It is given in the question that is z equals to 0 and z equals to 3. I have plotted it, and we have a equation that is x square plus y square equals to r square. That is equation of the base of the circle, and we know that height is 3 meter. So we will write it here. Now from here we can get y square. Use this equation. We can rewrite it as y will be equals to 4 minus x square root under. We have brought this x square on this side, then 4 minus x square, and y square means on if we move y square to other side it will get root. So root under y square, and root has two value, positive and negative, so it will have two limits, minus root under 4 minus x square, and other will be positive 4 minus x square. This is the limit of y in terms of x. Now for getting the limit of x we need to put y equals to 0. So if we put y equals to 0, then we will have x square equals to 4. So x will be equals to plus minus 2, because x will be equals to root under 4, and root has two value, positive and negative, so we will get x equals to plus minus 2. Now minus 2 plus 2. Now we will integrate it one by one using these formulas which I have already shown you at the beginning of this video. Now simply integrate and put the values and find the answer. So I have integrated it here. See here we have 4, and here it is nothing, means 1. So integrating with respect to z, we will have z minus 4y. Here z is missing, so z plus z to the power 1 means z to the power 1 plus 1, 2 divided by 2, and dy and dx. Now put the limit. So first of all we will put the upper limit, and then we will put the lower limit. So on putting lower limit means we will put for z equals to 3 for each and in each and every term. So 3, and here it is z, so 3, and z square means 3 square. Now lower limit is 0. So if we put 0 in each and every term, then all will get 0. So I haven't written it again here. Just it will be the increase of this line and nothing else. So on solving this we will get 12 minus 12y plus 9, and on adding we will get 21 minus 12y, and putting the value of z. Now we will integrate this with respect to y, and we will put the limit of y in the next step. Now integrate minus 2 to on integrating this with respect to y, we will have 21y minus 12y square and put the limit, that is minus root under 4 minus x square root under 4 minus x square dx. Now we have integrated this with respect to y, and now we need to put the limit, upper limit and then lower limit, and then again we will integrate this equation with respect to x to get final answer. Sorry, integrate, and then we will get the final answer. And here it is y square upon 2, so 2 6 is 6 times 12. Here we will have 21y minus 6y square. So see here, we on integrating this with respect to y, we will get we are putting the we have already integrated this with respect to y. Now we are putting the limit, so 21 y means first we are putting the upper limit, so here it is upper limit 4 minus x square minus 6 y square means square of this 4 minus x square will be 4 minus x square, root get cancelled with square, so I have not shown here, minus. See here, and here we will have, when we are putting upper limit and lower limit, we have first up when we put upper limit, then lower limit will be minus, so here it is minus and this whole bracket, and this we are putting the upper limit, lower limit now, so 21, and lower limit is minus 4 times x square, so minus 4 times root under 4 minus x square, positive, and here it will, sign will change in the lower step, it is minus for this time until we are putting the values here, so minus 6 and y square means minus 4 times 4 minus x square whole square. Now we have this much portion will be as it is, we have simply multiplied it, 6 times 4 will be 24, and minus will be minus, and minus minus get positive, and 6x square. Now we need to change the sign now, so on multiply, this minus will get multiplied with this minus, and it will get positive 21 times 4 minus x square. Similarly here it is minus and here it is minus, so minus and minus will get positive, and 24 minus this square gets cancelled with root, and we will have this minus will get turned into positive due to this square, and this minus and this minus on multiplying we will have positive, and this is already turned into positive due to square, so 6 times 4 equals to 24, and this plus 6x square. Here it's going to be negative, because see here, this due to this square, this negative turns into positive first. Second, this minus and minus on multiplying with each other, it will become positive, so positive 6 and positive 6, and on multiplying this minus it will get negative 6x square, and positive up to here we have positive 6, so positive multiply by 4 positive 24, and positive multiply with minus, so negative and 6x square. I hope you understood this step. And now and this 24 and this 24 get cancelled, this 6x square get cancelled, and on adding these two we will get 42 times 4 minus x square, so we can rewrite it as integration of minus 2 to 2 42 times root under 4 minus x square with respect to x. We can rewrite it as integration of 0 to 2 and 2 times 42 root under 4 minus x square dx, because the value is repeated, minus 2 to 2, sorry, minus 2 to 0, and again 0 to 2 times, so we can directly write it as 0 to 2 and 2 times 42 and then equation. So now integrating this with respect to x, we will have, so we need to integrate now root under a square root under 4 minus x square. It is in the form of integration of a square minus x square, and we have a formula, integration of a square minus x square equals to this much portion. So I have retained the integration of this in this form, that is 1 by 2 times x root under a square minus x square. In terms at place of a we have 4, so 4 minus x square by 2 plus 1 by 2 a square by 2, and we have a means 4 2, here it is 4 means a square equals to 4, and it means we have a equals to 2, so a square by 2 means 4 by 2 sine inverse x upon a is 2, integration of 0 to 2. Now put the limit first upper limit and then lower limit, we will get 84 times root under 2 times sine inverse 1, means here it is 2 upon 2 means 1, 2 upon 2 means 1, sine inverse 1 value is pi by 2, so we will get 84 pi. Now if you have a look to the equation, then we have got the value of this much portion. Now we need to find the surface integration of the vector f. So how it is done, see here. Now see here guys, we have surface integration. Now we will be doing surface integration. See here, we have three surface. This first is lower surface where z equals to 0 and the equation is x square plus y square equals to 4. Second one is z equals to 3, that is another surface, and the third one is this circumferential portion. This cylinder has three surfaces. First one is the bottom circular or top, and the third one is this curved surface. I hope you are getting. There are three surfaces, so we need to find the surface integration of this vector f 3 times for upper surface at z equals to 0, z equals to 3, and for this equation x square plus y square equals to, first z equals to 0 at z equals to 0, z equals to 3, and third one will be for x square plus y square equals to 4. We will be doing each and every step. Now see here guys, so we can write it here. S1 equals for S1 our first surface is at z equals to 0, second surface is at z equals to 3, and the third surface is the curved surface, that is x square plus y square equals to 4. I have mentioned it previously also. Now we can write it as surface integration of f and s equals to this first surface plus second surface plus third surface. Surface integration of first surface, second surface, third surface will be surface integration of this whole circle, because we have divided the closed cylinder into three parts: first part, second part, third part. Now we are discussing about the first part, that is S1. For S1 we have z equals to 0. Now if we will have z equals to 0, means we have unit vector n cap equals to minus k vector, because for first surface is on the plane. This is on the plane, and here it is on xy plane. So and here further we proceed below, then k value will be negative k, and listen, I is for x, j is for y. These are unit vector along x-axis, the unit vector along y-axis, and z is for the unit vector. For z it is k, unit vector along z. And further from this origin, as we move down it will get negative, and if we move up then it will be positive, and up to z it will be negative. So here we will have unit vector of n cap equals to minus k, because it is on the surface xy plane, so we have minus k, n cap equals to minus k, and we have vector f vector equals to 4x y cap. Here j terms, we have the equation vector f vector equals to 4x times I cap minus 2y y square times j cap plus z square times k cap, and here it as this force is on xy plane, so this term will get omitted. So we have vector f equals to 4x times I cap minus 2y square times j cap. Now we need to find the product of f vector into n cap. So if we multiply this k with I cap, it will get 0. Similarly j cap with k cap, it will get 0. So first we have surface integration of the first surface at z equals to 0 equals to 0. Now we will proceed for the second surface, that is z equals to 3. Process will be same, only the value of n cap will be varying, and this equation this vector f will be the same, and we on finding the product we will get some value here for z equals to 3. See how it is done. Now see here guys, we have at z equals to 3 n cap will be equals to positive. As I told you that further as we move up, the value of k will be positive, so positive k cap, and f vector is 4x times I cap minus 2y square times j cap plus 9k cap. Here the k, now we are having the k term because z is having some value. In the previous equation when z was 0, means it was on the xy plane, but here this time this force f is not on xy plane, so we will have the k term also. Now finding the product, we will have k, because on k cap is multiplying with I cap 0 and this 1, so 9 multiplied by 1 we get 9. Now we have 9 dx dy, and surface integration means surface and the upper surface is a circle, so on surface integration of 1 or constant we will have pi r square, and the r is equals to 2 in the given equation, so we will have 36 pi, and this is for S2 means second surface. Now we will find for the third surface. So guys, we know that n is the unit vector along the surface S3, that is normal, n is normal vector, and the n cap equals to gradient of that vector divided by the determinant of that vector. So see here guys, while calculating the gradient, what we need to do is we have to multiply this equation x square plus y square minus 4 equals to 0 with this. So on doing so, we need to multiply this first with this is curl upon curl x, so this x will integrate x only, so we will have derivative of x square will be 2x. Derivative of x square, we need to find the derivative of this equation with respect to this much portion only, because this is the value of divergence. Delta represents the divergence, and this is the value of delta, and we know that n cap equals to gradient or divergence of phi, so we need to multiply gradient value with phi, and we have phi is this equation and gradient is this value. If you ask me then to rewrite the equation, then let me show you here. So now see here, it will be easy now. The derivative of x square with respect to x is 2x and I cap, so put it here I cap, plus derivative of y square means with respect to y, derivative of y square with respect to y, it will be 2y and multiply by j cap. Similarly, derivative of minus 4 with respect to k, it will get 0. So because we know that derivative of constant is 0, so this is the value of the gradient of x. Now determinant, for determinant of gradient of x, what we need to do is we have to write it as root under a square, means coefficient of I square, coefficient of j square. So it will be here 2 square means 4x square plus 4y square. This is the unit vector along the surface S3. Now see here, we now this 2 and this 2 gets cancelled, and we have in the lower portion we have root under x square plus y square. We have x square plus y square equals to 4, so root under x square plus y square will be equals to root under 4. Root under 4 means equals to 2, so here it is 2. Now on finding the product of f vector into unit vector, we will get 2x square minus y square, because I will get multiplied with I and j will multiply with j, and we will get this much value for the product of f vector and n vector. Now one more step is remaining, and in that portion, then that step we will be adding the each surface integration of each and every value or each and every surfaces, and then we will get the final answer. Now see here guys, we have an equation that is x square plus y square equals to 4. Now we can write it as, this is in the form x square equals to plus y square equals to r square, and we can write it as that a is equals to r cos theta, means a will be the coefficient here. A is the coefficient of x square, b is the coefficient of y square, so a will be equals to r cos theta. Similarly, b will be equals to r sin theta. These are the value of here from 0 to on x-axis, from origin to this line value is r cos theta. Similarly, this value is r sin theta. So here we have a and b, and that is r cos theta and r sin theta. Now we can write here for S3 means surface 3. See here guys, surface 3 is our circumference, so we are calculating the value of x and y on this circumference, and for that we have S3. For S3, that is equation x square plus y square equals to 4. We will have x equals to r cos theta, means 2 cos theta. Similarly, y equals to r sin theta, so 2 sin theta, and ds will be equals to d theta multiplied by dz. And the third surface we have two surfaces, one is z and another is x. So in order to cover that equation x square plus y square equals to 4, the whole circle, we will have z must vary from 0 to 3, z must vary from 0 to 3, and theta must vary from 0 to 2 pi to cover that whole cylinder. So we will have here surface integration of S3 f vector n cap ds will be equals to theta must vary from 0 to 2 pi and z must vary from 0 to 3. Here it is in the diagram that circumference is in z axis, and we have also theta, and the theta is here varying from 0 to 2 pi. And put the value of f vector into n cap, and we have got the value of f vector into n cap equals to 2x square minus y cube d theta 2z. This is ds. It will be equals to d theta into dz, and multiply by 2 times. We need to take it 2 times. So 2 times d theta and dz. This is the limit of z, so I am going to write z in front of theta. So 3 2x square minus y cube, and this is multiplied by 2 and dz and then d theta. First of all, find the integration with respect to z and put the value, and then we have also got x and y in terms of theta. So in place of x we will write the value of x equals to that cos theta. So 2 times x is 2 cos theta square minus y is 2 sin theta to the power 3 multiply by this 2 dz and then d theta, and we will have a bracket right here. So now we have multiplied the constants, and we had cos square theta minus 3 sin cube theta and 3 d theta. So 16 multiplied by 3 48, and this integration of 0 to 2 pi cos square theta sin cube theta. On integrating this we will get pi and 48 pi, and from here we have the proved that divergence theorem is valid for this equation, because we have got the surface integration of vector n and the product of vector perpendicular to the surface n cap is equal to 84 pi, and previously we had also got a divergence volumetric integration of that f vector was also 84 pi. So LHS equals to RHS, it means it is proved. And I hope you enjoyed this lecture. If you want more videos related to engineering mathematics, then do comment on this video, and see you in the next video. Till then, stay safe and take care of yourself.